Sir Isaac Newton observed that the force which is responsible for the movement of moon around the earth, the force which is causing the apple to fall down, the force which is holding us to the surface of the earth, all are the same. He named it gravitational force. So what is gravitational force? Gravitational force is the force of attraction between two objects having some mass. And the phenomenon of attraction is called gravitation. Based on his observations, Newton developed universal law of gravitation. What is universal law of gravitation? Every body in this universe attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. We can understand this with the help of an example here. We have two masses m1 and m2 separated by a distance r. And see, the distance is measured between the centers of these masses. According to this law, the force is directly proportional to the product of the masses, that is F proportional to m1 into m2, and inversely proportional to the square of the distance between them, that is F proportional to 1 by r square. We can combine these relations to get F proportional to m1 m2 divided by r square. We can change this into an equation by giving a proportionality constant, which is g here. So we get the equation as F is equal to g into m1 m2 divided by r square. What is the value of g? G is equal to 6.67 into 10 raised to minus 11 Newton meter square per kilogram square. This value was given by Henry Cavendish. It took around 100 more years after the universal law to experimentally determine this value. And see, what is the effect of mass and distance on gravitational force? So from the expression, it is clear that force is proportional to mass and inversely proportional to square of the distance. So if I double one of these masses, what will happen to the force? The force will also get doubled. If I double the mass of both these objects, force will become 4 times. What happens if I double the distance? The distance is in the denominator. So the force will become 1 by 4th. This is how mass and distance affect the gravitational force. Now, properties of gravitational force. What are the properties? The first property is that it is always attractive in nature. So we have considered two masses. M1 is attracting M2 towards its center and M2 is attracting M1 towards its center. The nature is always attractive. And it acts between any objects having some mass. It is a central force because the force is acting along the line joining the centers of these masses. Does not depend on the medium. If I place the same example inside water, what will happen to the magnitude of the force? The magnitude will not change because it does not depend on medium. And it is a long range force. And it is the weakest force in nature. We know there are 4 fundamental forces and gravitational force is the weakest of all. We have discussed the properties of gravitational force, and the last one is very important to you. It obeys inverse square law. What is inverse square law? We know the force is directly proportional to 1 by r square. The dependence of force on distance like this is called inverse square dependence. And gravitational law obeys that. And what is the importance of gravitation? Planets revolve around the sun due to the gravitational force of attraction. And objects fall towards the earth, holds the atmosphere and causes tides. So these are some of the examples that we know. When you observe your surroundings, you can see that everything that we drop falls towards the surface and everything around us is held together to this surface. All these are due to gravitational force.